Okay, hi guys. So I'm going to do two of these problems with you. If you don't feel the need, like for the, to stay with me, you could go ahead and try it on your own. But so the volume of a sphere is increasing at a constant rate of 272 cubic centimeters per second. At the instant when the volume of the sphere is 34 cubic centimeters, what is the rate of change of the radius? The volume of a sphere can be found with this equation here. Okay, and we'll round to 3 decimal places. So let me translate. Well, first let me draw a picture. So we've got a sphere, because a picture always might help you. All right, so we've got a sphere. This is its radius. I'm not good at drawing, but I don't know. So there's a sphere, I guess. Okay, and the volume of the sphere is increasing at a constant rate of that. So this is a rate, so they're telling us that dV dt, so the change in volume over the change in time, that's what that means, is 272 per second. At the instant when the volume of the sphere is 34 cubic centimeters, so at a certain instant, the volume of the sphere is 34 cubic centimeters. What is the rate of change of the radius? So what we want is dr dt. That is we're going to figure out what we want. Now okay, so let's write this formula down. So V equals 4/3 pi r cubed. Now, you look at the formula that you're working with, and there's two variables, V and R. At a certain moment, V is 34. So that must mean at this certain moment when V is 34, R must also have a certain value at that moment. So we should find it now, and then maybe we'll use it later, maybe we won't. And the more of these problems you do, you'll get a sense of when you'll need something and when you won't. But so at V equals 34, all right, so at V equals 34, we can go 34 equals 4/3 pi r cubed. Okay, so I'm going to just divide both sides by this, and then I'll have r cubed equals 34 over 4/3 pi. And then so to get r, you would take the cubed root. So r is the cubed root of 34 over 4/3 pi. And I guess I'll just leave it like that. You could get a decimal, I guess, and store it in your calculator. Maybe we should. I'll just leave it like that. Okay, so that's what r is. So yeah. Now we want dr dt. So just like before, guys, with the rectangles and triangles, you're going to take the derivative of this. Remember, pi is a number. Okay, so this whole thing out front is just a number. So, okay, so this is going to be v prime equals, and guys, stop and discuss this if what I do doesn't make sense. Okay, make sure you understand. So this is, I'm going to multiply that by 3. So it's just 4 pi r squared. That's the regular derivative, but everything gets a prime after it because dt is on the bottom. So v and r are on the top, so they get primes after both of them. Okay, so we want r prime. So I'm just going to leave blanks for everything but r prime. So what's going in for v prime is this. 272. What's going in for r is what we found here. So that'll be the cubed root of 34 over 4/3 pi. Okay, and then, you'll just divide both sides by that. So, and you could use your calculator, guys, as you go along. I don't have one in front of me, that's why I'm not using it. But this is I have to grab one in a minute though. So it's going to be 272 over 4 pi cubed root of 34 pi squared. Okay, and then I'll just plug that into the calculator. So, yeah, and I don't know if you guys know this, but, oh, there's the alpha y equals feature, but on my calculators, because they have like an update, you could go alpha and then this one right over. Oh, you can't even see it. Wait, no, that doesn't work. It didn't work on this. Alpha y equals, all right, I guess I have to do that. Darn, you can't even see what I'm doing because it's too bright or something. You see now? No, you still can't see. Okay, so let me just do this off camera. And you guys could do it at the same time as me, and we'll see if we get the same solution. Okay, so I got r prime is 5.359, and our units are going to be, so a radius is a length, so centimeters per second. Okay, and guys, if I had the calculator in front of me, I think I would have just gotten, just plugged this into the calculator here and then stored it. Help each other if you don't know how to store. Like if you want to, have a discussion right now about how to store things, you can. When I get back, we'll definitely talk about it. So that might have been easier. Like if you just stored, for sure easier, I think, if you had just stored this in your calculator and then used the variable you stored it as here at the end. Okay, so I'm gonna do number 2 also, and you guys can choose, if you stay with me in the video or not, or try it on your own. But this time, the radius of a cone is increasing at a constant rate of 7 meters per minute, and the volume is decreasing at a rate of 236 cubic meters per minute. Okay, so the radius is increasing, but the volume is decreasing. At the instant when the radius of the cone is 9 meters and the volume is 180 cubic meters, what is the rate of change of the height? And then the volume of a cone can be found with this equation. All right, so same as before, we're going to translate this stuff and then find whatever, variables in the original equation that we can. So, all right, so we're going to be using, so we've got 3 things changing here, V, R, and H. So the radius is increasing at a constant rate of that. So that's dr dt, it's increasing, so positive. And the volume is decreasing at a rate of 236. At the instant when the radius of the cone is not, oh, I should have drawn a cone, by the way. I guess. All right, let's draw a cone. Usually they're like upside down. All right, so this is the height. That's the radius. All right. Okay, at the instant when the radius of the cone is 9 meters, so at r equals 9, and the volume is 180 cubic meters, what is the rate of change of the height? Okay, so so up here with the rates, I'll write dh dt equals what, question mark. That's what we want. So guys, if we have, at this moment, if r is 9 and v is 180, then h must also be something at that very moment. So, since we know this, we can find h. So this is 180 equals equals a third. Okay, and you guys are very good about like, you know, asking questions. So please like pause the video, ask each other questions if you don't understand. So this is, all right, so H is going to be equal to, all right, I'm just going to get a decimal, 180 divided by okay, so in my calculator, I got 2.122065908. All right, but that keeps going. Actually, that's an irrational number. So I'm going to store this, and the store button. Where is it? The store button is right there. So if I hit store, yeah, you still can't see that. And then I'm just gonna choose like some letter. I could even choose H. Where's the H? H is above here. So I hit store and then I hit alpha and then this and enter. So now this is stored as H. So I can say store this, and I stored it as H in my calculator. Yeah, so now I could use it later. So, all right, now you take the derivative, and we need product rule for this, guys. So this is going to be the first function, and then that will be the second function. So V prime equals, all right, the derivative of this first part is 2/3 pi r, but then it needs an r prime, and then you bring down the h, plus, now I bring down the first one, the derivative of h is 1, but we need an h prime after it, so just h prime. All right, and if that is not clear, please talk to each other. All right, now I'll do, you know, the blank stuff. So I'm looking for h prime, so I'm going to leave a blank for everything but h prime. That's just how I like to do it. So this 2/3 pi blank 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 is 1/3 pi blank squared h prime. Okay, what goes in for v prime? 236. What goes in for r9? R prime. Oops, you guys probably already caught this. The volume is decreasing. I'm sure you caught this a long time ago. That should be negative. Whoopsie. This is probably driving you crazy this whole time. All right, so that should have been a negative. All right, now what goes in for H? I stored it. So I'll put a capital H. As long as you're telling your reader, like, I stored this as H, then we're allowed to, like, use it in our expression because they should understand what we're doing. And then this is an R, so that's 9. Right there. Okay. Now, this is... Okay, so I have to... Let me consolidate this a little bit. So anyway, this is negative 236 equals... I'm going to do the 2/3, the 9, and the 7. I'm going to multiply them. 2/3 times 9 times 7 is 42. So this is 42 pi with the h plus, this is 27 pi h prime. Okay. So then I'm going to subtract this from both sides and then divide both sides by the 27 pi. So we end up with h prime being negative 236 is 42 pi h, which is stored in my calculator. Okay, now I'm going to plug all that in. negative 6.083. And now a height is a length, so it's going to be meters per minute. Alrighty, guys, I'm really having fun doing these with you guys this year. You're catching on so fast, so I hope that was clear. And I hope that, no, I'm sure I'll be back by Tuesday. I'm sure this won't last that long. All right, so I'll talk to you later. Bye-bye.